Let's talk about documenting system design, future, and value engineering. A system you can document is a system you can defend. If the drawing set doesn't tell the story, your design does not exist. In this context, what is the purpose of the documentation? It isn't just paperwork. It is the bridge between design intent and installation reality. It defines what to build, how to build it, and how to verify it works. Without it, projects collapse under assumptions. Design is communication, and drawings are the language. So, what system documentation must cover? Every AV design must document fabrication and installation requirements, system functions and operations, quality expectations. The documents guide bidding, procurement, and commissioning. If details aren't written, they won't be executed. Remember that, because clarity prevents variations and rework. Functional diagrams show how everything talks. Sources are typically on the left and processing in the middle, with outputs on the right. Each connection labeled with signal type and direction. This one diagram tells you if the system even works on paper. And if the signal path isn't clear on paper, it won't be clear on site. Another one is the architectural connectivity. Connector panels, floor boxes, cable ducts, document them all. They decide how architecture meets technology, specify connector types, labeling, and conduit requirements. Cable length must be planned early to avoid attenuation and space conflicts. Infrastructure drawings protect coordination with other trades too. The supplemental set are as important. You need rack elevations to confirm thermal, space, and access, panel layouts to show connector pinouts and labeling, custom configurations, internal jumpers, dip switch settings, patch panel layouts to maintain organized signal management, and user interface descriptions to define graphic user interface logic and button flow, often referred to as wireframes. Each drawing removes one layer of installer ambiguity. And when it comes to the shopping list, there's nothing more important than the bill of material. The bill of material, or the BOM, is the project ledger. Every item, every quantity, every accessory. When you build this, categorize it by function. Sources, processors, destinations, control, infrastructure. Include pricing if required, but never without revision tracking. The BOM turns vision into procurement. And then you got future provisions. Future-ready systems save future budgets. Remember that. So design spare capacity, extra inputs on switchers, extra pairs in cable pulls, wider conduits, spare rack space, and additional control ports. Clients don't thank you today, but they will in 3 years. Scalability is value disguised as foresight. New engineers often confuse value engineering with cost cutting. It isn't, it's cost optimizing. So eliminate redundancy and not reliability. Combine functions where efficiency gains exists. So for example, you could replace a discrete scalar plus a DA with integrated matrix if specs align. But always protect performance and serviceability. Real value engineering is about reducing waste, not capability or compromising on specifications. And always remember that design accuracy depends on measurement discipline. Use modeling software for acoustics, projection, and coverage. Use spectrum analyzers, oscilloscopes, and packet sniffers for validation. Never guess. simulate, and verify. Because at the end, those measurements converts theory into proof. Documentation makes a design reproducible. That's the objective. Future-proofing makes it sustainable, and value engineering makes it efficient. Each reflects professionalism more than any brand or product choice. If someone can rebuild your system from your drawings and it performs identically, you've done your job well. Documentation is not the end of the design, it's validation. Here is what we covered in this video. We covered display systems, purpose-driven design, bandwidth awareness, and routing integrity. We covered audio systems, intelligibility, loudness, and stability as design pillars. Control systems, simplifying complexity through functional clarity and feedback. IT integration, bandwidth, latency, and governance as non-negotiables. And finally, we covered documentation plus future engineering, communicating design intent, planning for scalability, and optimizing cost without compromise. Design is both art and accountability. Your drawings, your math, and your understanding of IT define your credibility.